Let's talk about how to calculate quartiles of ungrouped numbers. So in this example, we are already given the numbers. The first step when we are given a set of numbers like this is to make sure they are arranged in increasing order. So these numbers are not arranged in increasing order, so I'll do that. How do we know if we don't make a mistake? You count these numbers here and you count these numbers here. They should be the same, or otherwise you made a mistake. So if I count this number, this is 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Then here I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So the total number of numbers we have is n is equal to 19. We're still going to use this. Now, how do we find the first quartile? The general formula for a quartile is given as qi is equal to I over 4, open bracket, n plus 1, 10. This formula simply tells us which of this term is the particular quartile we're looking for. So if you're looking for the first quartile, we need to use Q1 here. That means this will be Q1 is equal to 1 over 4. The I here is simply the same thing as I here. So this will be, remember our total number of values here is 19. It will be 19 plus 1. And then this is equal to 20 over 4. 20 over 4 is the fifth term. So that means our first quartile is placed in the fifth term. So we come here and count the fifth term. This is the first term, this is the second term, this is the third term, this is the fourth term, and the fifth term. This means that, or this implies that our first quartile is equal to 3. For the second one, we're asked to find the second quartile. So we still use the same formula that we used to find the position of the first quartile, which will be Q2 is equal to 2 over 4, open bracket, n plus 1. From here, I know that n is 19, so this will be 2 over 4, open bracket, 19 plus 1. This is equal to 2 over 4 times 20. You can say 2 here is 1, 2 here is 2. So this means that 20 divided by 2 is equal to 10th term. So we are looking at the 10th term for the second quartile. That means this is Q2, which is equal to, the 10th term here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the 10th term is 5. That means the quartile here is 5. First find the third quartile. Let's clean up space. So remember, the first quartile is equal to 3. The second quartile, this is also known as the median, is equal to 5. The third quartile, we use the same formula to find the position for the third quartile. So the third quartile is located at a 3 over 4, open bracket, n plus 1's position. So that we can say the Q3 is equal to 3 over 4, open bracket, n is 19. So we know that this is 19 plus 1. And this is equal to 3 over 4 times 19 plus 1 is 20. You know that 4 into here is 1. 4 into here is 5. So that this is equal to 3 times 5. 3 times 5 is equal to 15. So we are looking at the 15th term for the third quartile. That means the third quartile is equal to, so we'll go here and count to find our 15th term. So this is our first term, our second term, our third term, our fourth term, fifth term, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that means our third quartile is 9. Let's look at another example. Say we are asked to find the median, the lower quartile, the upper quartile, interquartile range, and the range of the following numbers. So we already have numbers on the screen. the first thing we can do is to arrange numbers in increasing order. The next thing we do is to count the numbers here and count the numbers here. They have to be the same, otherwise we've made a mistake. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Since they are the same number, that means we got it correctly. Now we know that the total number of terms here is 12. The first thing we're asked to find is the median. The median is also equal to the second quartile. So median is also equal to Q2. And remember, the formula for quartile, the general formula for quartiles is QI is equal to I over 4, open bracket, n plus 1. In this case, since we have Q2, which is quartile, second quartile, this will be equal to 2 over 4, open brackets, n is 12, so 12 plus 1, close bracket. And then this is equal to 2 here is 1, 2 here is 2. We have 1 over 2, open brackets, 13. This is now equal to 13 over 2. 13 over 2 is the 6.5. 6.5. So we are looking at the 6.5th term. Since we are looking at the 6.5th term, our median, which is also equal to our second quartile, is equal to the 6th term plus, remember this is 0.5, so this is plus 0.5. If we have a number line like this will be the 6th term and this will be the 7th term, right? The 6.5th term will be somewhere around here. We can interpolate and say this by 7 minus 6. So that means it will be the 7th term minus the 6th term. So that from here we can have the median to be equal to 6th term is, what's our 6th term? This is the first term, the second term, the third term, fourth, fifth, sixth. Our 6th term is 22. This is 22 plus 0.5, open bracket. So this is 25 minus 22. From here we know that this is equal to 22 plus 0.5. 25 minus 22 is 3. From here we have 22 plus 0.5 times 3 is 1.5. So that we have this is equal to 22 plus 1.5, and that is equal to 23.5. So that's the median. Let's look at the lower quartile. We got our median, which is also Q2, as equal to 23.5. And in this case, we are told to find the lower quartile. The lower quartile is also another name for Q1, or the first quartile. So this is Q1. Can be 1 over 4, open brackets, n plus 1. And then that means that Q1's term is equal to 1 over 4, open bracket, 12 plus 1. From here we know that 12 plus 1 is 13. And then divided by 4. 13 divided by 4 is simply 3.25. So we are looking at 3.25th term. 3.25th term equal to the third term. We'll look at the third term plus 0.25, open bracket. Now 3.25 falls in between the fourth term and the third term. So that means this will be the fourth term minus the third term. So we go to our list and get those terms. The third term in our list is, this is the first term, this is the second term, this is the third term. The third term in our list is 12 and the fourth term in our list is 14. So that's our lower quartile will simply be 12 plus 0.25, open bracket, 14 minus 12. This will be equal to 12 plus 0.25, open bracket, 14 minus 12 is 2. and then this is 12 plus 0.25 times 2 is 0.5. 12 plus 0.5 is 12.5. So the lower quartile for this problem is 12.5. Let's look at the next example, which will be finding the upper quartile. So remember that the lower quartile, which is Q1, is equal to 12.5. For the next thing, the upper quartile, which is equal to Q3. Now, if you use the general formula of a quartile, this will translate to 3 over 4, open brackets, n plus 1. 3 over 4, open brackets, n is 12 plus 1. And then this is equal to 3 over 4, open brackets, 13. From here, we know that 3 times 13 is 39 divided by 4. 39 divided by 4 is simply 9.75. So we're looking at this 9.75th term. That means the upper quartile will rest in Q3, will be equal to the 9th term plus 0.75, open bracket. Because you have 9.75, that falls in between the 10th term and the 9th term. So this will be minus 9th term. I'll go to my list and get my 10th term and my 9th term. This is my first term here, my second term here, my third term, my fourth, fifth, sixth, seventh, eighth, 9. This is my 9th term, which is 36. This is my 10th term, which is 42. So that my upper quartile will be 36 plus 0.75, open bracket, 42 minus 36. This will be equal to 36 plus 0.75. 42 minus 36 is 6. And then from here, I have 36 plus 0.75 times 6 is 4.5. So from here, we know that this is equal to 36 plus 4.5 is 40.5. So my upper quartile is 40.5. Let's look at how to find the interquartile range. So remember, the upper quartile is equal to 40.5. The interquartile range is simply equal to upper quartile minus the lower quartile. From our question, we already have our upper quartile, already have our lower quartile. So that means this is equal to 40.5 minus 12.5, which is equal to 28. For the last one, we are asked to find the range of the numbers. So that the range would be the highest number minus the lowest number. The highest number here is 65. So that's the highest number. The lowest number here is 5. 60 minus 5 is equal to 60. Sometimes when we ask to find the semi-interquartile range. So the semi-interquartile range is equal to Q3 minus Q1 over 2. We already know Q3 minus Q1 as 28, which is the interquartile range. So that means this is equal to 28 over 2. 28 over 2 here is 14. So that's it. That's how to calculate quartiles of ungrouped data. If you like the video, give it a thumbs up, share with your friends, and subscribe to the channel. Thank you for watching.